Today I will discuss trial KML 23-24 question 3. So usually question 3 in a paper trial or PSPM, usually chapter 4. So let's discuss. So this is the question of KML 23-24. Let's start with 3A1. Draw the Lewis structure of the three resonance structure of the thiocyanate ion. First, we need to determine the number of electron such S have 6 electron times 1 equal to 6, C 4 electron times 1 equal to 4, and N 5 electron times 1 equal to 5. Total up of this is 15. Because since the ion have the negative charge, we need to plus 1 and total up is 16. Then we need to sketch the basic structure. So we need to decide who is the center atom of the structure. Since C has less electronegative elements compared to the sulfur and the nitrogen, so C need to be the center atom. And the structure will be like this, with the sulfur and the nitrogen bonded with the carbon, with the carbon as the center. First, we need to complete the octet of the nitrogen and the sulfur first by adding the 6 electron or 3 lone pair around it. Since the C not have the full octet, we need to form multiple bond by sharing electron between the atom. So let's do the structure 1. Structure 1, single bond between the sulfur and the carbon and triple bond between the carbon and the nitrogen. Sulfur have a 3 lone pair, 1, 2, 3, and the nitrogen just 1. This is structure 1. And structure 2, double bond in sulfur and double bond in nitrogen, which sulfur and nitrogen have the equal bonding pair and the lone pair. And the structure 3, single bond between the nitrogen and carbon and triple bond between the sulfur and the carbon, and the lone pair on the sulfur has 1 and in the nitrogen has a 3 lone pair. So between the structure, we need to put the arrow because the resonance of the structure. So how you will get the mark? If you write the structure 1, you will get 1 mark, structure 2 1 mark, and structure 3 1 mark. 3A2. Determine the most possible structure and give your reason. So how we determine the most possible structure? We count the formal charge of each structure. So you can count the formal charge like this. You write one by one, or just show the formal charge on the structure like this. If you write like this, each structure you will get 1 mark. 1 mark. 1 mark. Either one. So the most possible structure is structure 2. So you just write the structure 2, you will get 1 mark. And the reason, give your reason. Because the smallest formal charge and the negative formal charge appear on the more electronegative atom, which is N. You will get 1 mark. Just like that. 3B1. Describe the hybridization of central atom in OF2. So how we decide the central atom? We need to know the valence electron. Like O have a 6 valence electron and F have 7 valence electron. Which since O have a less valence electron than F, so O will be the center atom. So how we describe? We can write the ground state of oxygen, which is O in the period 2, so 2s and 2p. So at side state of the O and hybrid state of O, we describe hybrid state of O. So by hybridization of O in OF2 is sp3. So how we get the mark? You write the ground state 1 mark, excited state 1 mark, hybrid state 1 mark, and type or hybridization 1 mark. 3b2. Draw and state the molecular geometry of OF2. First, we need to determine total number of valence electron and such. O have 6 valence electron times 1 equal to 6. Fluorine 7 electron times 2 equal to 14, and total up is 20. Then we need to decide who is the center atom of the structure. The center atom of the structure is the less electronegative. So since O have less electronegative than F, so O will be the center atom. Then connect two fluorine atom to the oxygen atom with the single bond. Then complete the octet for the fluorine atom. For the fluorine atom, each fluorine should have 3 lone pair, 1, 2, 3, 3 lone pair, or 6 electron around each fluorine. 3 lone pair, 1, 2, 3, or 6 electron. 1, 2, 3, 4, 5, 6. 6 electron around each atom. So, from this, we can predict the basic structure and the molecular shape for OF2. So, since I have a 2 lone pair, 2 bonding pair, total up is 4. 4 stands for tetrahedral for basic structure. So, basic structure for OF2 is tetrahedral. Then molecular shape, we see the class. Class AB2E2. See AB2E2, the molecular shape is V shape. Then draw the molecular V shape. So V shape. So how will get the mark? Molecular state 1 molecular shape 1 mark, and the draw 1 mark. 3b3. Predict the polarity of OF2. Since the molecule is not symmetry, so the dipole moment cannot be cancelled out. So OF2 is a polar molecule. So you will get 1 mark. Dipole moment cannot be cancelled out, and 2 mark. And 1 mark at OF2 is a polar molecule. 3c. Explain why calcium has a higher boiling point than potassium. You can write because Ca is smaller in size than K, or Ca has a greater number of valence electron than K. So Ca has a stronger metallic bond. So you write between these two, you will get 1 mark. Then you write Ca has stronger metallic bond than K, you will get 1 mark. Just that.